We're joined from space today by Discovery Commander Dick Richards and Mission Specialist Jerry Lininger. Gentlemen, the first thing I want to talk to you about is what it was like during the launch of your mission. Dick, you've been to space many times before. Jerry, you were a rookie on Friday night when the shuttle lifted off. Tell me, Dick, you start first, just how this liftoff compared to previous ones, and then Jerry, tell me what it was like for you to do it for the first time.
Well, John, for me, I've been real fortunate in the fact that 3 of my previous launches all have gone within about 30 minutes of the planned launch time. So as you know, we had some very iffy weather down there at Kennedy Space Center a couple days ago, and I know most of our attention in the cockpit was looking around outside the windows trying to guess what the weather decision was going to be. For a while it looked pretty bad, but then all of a sudden the blue sky started showing up, and all of a sudden optimism within Discovery got a lot higher, and that was seconded by the comments we started receiving from the weather team on the ground. So we went from a little bit of being a little despondent to enthusiastic because we thought we had a chance to go, and finally 2 hours into our launch count we got off the ground. So it was from sort of the agony of defeat to the thrill of victory there for us, and I think everybody was excited. Jerry can comment though on his first space flight experiences.
Yeah, extreme excitement. It felt, I kind of thought it was like a herd of buffaloes I was in the middle of, and everything was shaking and rattling, and we were really moving, no doubt about it. And then about 2 minutes to go before the engine shut off, it felt like about 3 of those buffaloes sat right on my chest as we had the 3 Gs and sustained them for a while. So, and then when we cut the engines, it was like everything jumped out and we were just floating, and just fantastic.
Yeah, Dick, did you lose radio communication with the ground at one point during the launch sequence?
Right after main engine cutoff, there was a period of about 4 minutes where apparently the Houston was unable to talk to us. However, all of the calls that we were supposed to have received got on board, so it was kind of invisible to us, and we were just marching along through the checklist, and there weren't any anomalies to be worked, so we didn't have any reason to call Houston. It was only later when we got some sort of indication that there was an unplanned communication drop, but it was basically invisible to us.
Yeah. How's the orbiter working right now? All the systems there behind you are in the right positions? All the lights on green instead of red?
They're all on green. We're in great shape here, and we're marching right along here. And in the background, which you can't see, we've got 2 crew members, Mark Lee and Susan Helms, activating the SpyFix experiment for the second day of operations there. If occasionally you see the camera wiggle, it's because they're trying to get their job done, so we'll apologize for that. But everything is looking good for the start of day 3 here.
Yeah. Jerry, what's been the most unusual thing, the most unexpected thing to happen to you since you've been in orbit?
Again, the launch, I just didn't expect quite the thunder and lightning and jumping around that we did. And then I guess the stark contrast between that and when the engine's cut off, where it's just kind of a floating sensation. Then again, looking at the Earth is just an absolutely fantastic experience, but I guess I expected that.
Yeah, can you see anything out the windows right now, or do you have them blocked to keep the light out of the cockpit?
Well, we've got the windows blocked directly behind us, John, just to make the picture look good for you all. But no, I can look off to my left here, and got a beautiful view of clouds, and I'm not sure. I think we're over the Pacific at this particular time. We've got our one computer occupied doing other things that usually keeps track of that for us. But it's a gorgeous view out over the ocean here.
The other day, Dick, you were talking about the environmental aspects of this mission and why it was so important to the Earth that you can see out the window there. I'm told, by the way, you're coming up over South America, probably the west coast of South America, so you are in the Pacific moving that way. You'll probably be over South America before we stop talking. But tell me about the environment of the planet, both of you, and what you think you might be able to do as astronauts and members of the space program to make the environment down here better, perhaps.
Well, there's so much potential. You know, we can look exploring both outward and inward, and looking out to the stars and our Spartan satellite we're going to launch to look at the sun and learn a little bit more about the medium of space, and then looking back toward Earth with all the environmental sorts of things that we can look at with our LiDAR experiment to look at the atmosphere and keep tabs of it. So I think there's a great
happens if you get a toothache? Go ahead.
Well, I was just going to comment, John. I have to say something about the primary payload for STS-64, the light experiment. It's the potential for a real advancement to add to our inventory of spacecraft in low Earth orbit. As you know, most of our spacecraft that we have up here are passive in nature. They essentially just take the light or the electromagnetic radiation radiated by the Earth and try to infer what the atmosphere is doing, particularly in the middle and upper atmosphere. So putting an active instrument, one that produces its own sorts of electromagnetic radiation and penetrating the Earth's atmosphere, trying to characterize it through that method is something different here as far as adding equipment to our mission to planet Earth objectives. So being part of that is pretty exciting for us, and I'm very hopeful. And the news we've gotten so far of the light data takes that we've taken so far indicates that this has got lots of potential for increasing our understanding of the middle and upper atmosphere.
I got to tell both of you, the Weather Department guys at CNN have been fascinated with the pictures of Tropical Storm Debbie from the light experiment. They're things that like nothing you can get from a regular weather satellite photograph. Well,
that's good to hear, John. No.
Go ahead.
No, that's good to hear. We just got a little bit of news in the morning mail that was sent up that they had been able to look at Tropical Storm Debbie, and that was very exciting. I wish we could see some of it.
Yeah, no kidding. It's too bad that we can see the data on the ground, some of it before you guys get to. The question I was going to ask you a couple of minutes ago, what happens if you get a toothache? I came into work yesterday morning with the first toothache I've had in about 20 years, and I'm thinking, well, I can go to the dentist on Monday. What do you do?
Well, we've got Jerry on board, so we'll let him answer that one.
Well, I'm a physician, and I usually don't mess with teeth very much, but Dick is my backup, and we also had a little dental training there, so we would inject. We've got a little medical kit down there with all the applications that we need. I don't think we'd want to pull a tooth, but we'd be able to temporize until we got back. And along those lines, if anyone else gets sick, we all do fine. I'm the one that's afraid of getting sick because Dick becomes my doctor.
Dick, you had your 48th birthday a couple weeks ago, and you've been flying in space for, I guess, 6 years now, maybe from your first mission to this. I may have the years a little bit off, but is it any different as a 48-year-old guy than it was 6 years ago? As far as how your body reacts.
I sure don't notice any difference. The only thing I have noticed on my fourth flight is the fact that my body's memory of how it experiences space flight, particularly the first few days, seems to be better because I'm overcoming the effects of being in a suddenly going from a 1G environment 8 minutes later being in a weightless environment much faster, and I guess I attribute that to the fact that my body just remembers what it's like to be in space. So I recommend lots of space flights for everyone.
I'm with you on that. Jerry, let me ask you this. You know, I'm sure astronauts don't like to exhibit any sign of weakness, physical or any other way, but I talk to astronauts who, after their first flight, generally have had some space sickness. Dick says he was better at it this time. How about you? Did you get sick? Did anybody get sick? And what did you do for them if they did?
Well, actually, we're all doing pretty well. We have some general, it's mainly nausea is what people feel, and we have some medications for that, and it usually does the trick. So it's just a couple-day thing for the most part, if it does at all occur. In my case, I felt great, and right off the bat, and I was rather surprised, to be honest with you. I had all kinds of game plans in mind, and luckily I didn't have to utilize any of them.
Is there a space version of an air sickness bag?
There is. It's very similar to any emesis bag. It's got a little fancier version, I guess, with the little closures on it, so that the, as you can imagine, the emesis stays where you want it to stay. As a matter of fact, we'll float one here, and there you can see it.
Fascinating, guys. Thank you for doing this. This is, the viewers who write into us really have questions like that.
I'll give you more details.
Let's talk more about the thing that seems to be most fascinating to people here on Earth about this mission. It's the spacewalk, the untethered spacewalking that Carl and Mark are going to do later. Both of you have critical roles to play in this, as I understand it. Jerry, you're going to be the monitor, and Dick, you're going to be there in case something goes awry. Tell me about what you have trained for, what you've planned for, and Jerry in particular, you're going to have your nose pressed against the back windows there, I guess, during most of this, aren't you?
More or less. I'm more or less choreographing the whole thing. I've been through training with Mark and Carl have done just an outstanding job. And I'm sure this untethered backpack safer EVA is just going to be absolutely fabulous. If I wasn't so busy, I'd be snapping pictures 100 miles an hour, I'm sure, because we're going to get some spectacular shots. But we've got Blaine Hammond that'll squeeze out of his duties, and we'll all try to get to the window so that you all can see a little bit of it.
So we're all looking very forward to this. I think I need to ask the worst that can happen question, though, to both of you. Dick, let's say something goes wrong with these jetpacks, and Carl Meade or Mark gets to a point where he can't get back unless you move the shuttle. How much have you prepared for that, and how would it work?
Well, we've prepared extensively for that. We've got some very good simulators in Houston, which I think we've about stepped through every possible scenario here for these failure modes that you referred to. Essentially, what would happen is, first, the most important feature of it is just to recognize that a failure has occurred. A lot of times, Carl and Mark, when they get out there, they get oriented into a position where they may or may not be able to see orbiter structure, so it's hard to tell then. They don't have anything to determine their rates from, and sometimes we can see it inside the vehicle more quickly than maybe what they can. Other times, if they do have orbiter structure, they see it much quicker than we do. It's just a question of recognition, and then there's just a few simple steps that we go through to save the safer system, and then it's a question of flying the orbiter over to them. I don't consider it very much different than what we would do, what we were going to do the day before, which is re-rendezvous with the Spartan satellite, grapple it, and put it back in the payload bay. It just, whether it's a human being or a spacecraft, once it's non-maneuvering, it's a question of just flying the orbiter up, getting it in a close proximity so they can reach out and grab an arm. It's much easier, of course, with a human because they've got eyes and hands to deal with, and so we just have to get them relatively close.
Yeah, okay. Jerry, one of your primary responsibilities on this mission is to look after these getaway special canisters, look like garbage cans to me, out in the cargo bay. What are some of the more interesting things going on in those?
Okay, I think the best way to describe it is just variety. They've got everything going on back there, distillation experiments, some microgravity experiments. We just looked this morning, and last night we opened up a door, exposed some ESA experiments, European Space Agency experiments to the atmosphere. I think one of the fun ones is the Utah State had an elementary school close by, and they had the students put some popcorn seeds in there, and then they have some back on Earth, and when we return, they'll be popping both kernels and see which type they like the best.
Yeah, you got a shot at any of that popcorn? Are they going to share with you at all, do you think?
Well, we've got a couple of crewmen on board that have a reputation for eating everything, so when they get close enough to that gas can on that safer EVA, we're going to be watching them real close.
Tell me something. This is a personal question, a human being question for both of you. It looks like you guys are having a heck of a good time up there. How much time do you get to have fun versus to do the hard work that you're assigned to do on these things?
I'm hesitant to tell you the truth there, John, because Mission Control would hear it and then put more work in there for us. But honestly, we've got a great work environment here, and just doing work is fun, in my opinion. Being able to get the experiments operating, the only time that we don't have fun is when the experiments here don't necessarily go the way that they should. And of course, we've worked with these people on the ground, and we know that they've put many years of work on almost all of these things on board. So we really feel for them when things don't work, but we're exhilarated when things do work properly. So just working and seeing these experiments that we've worked on for years come to fruition is one of the more exciting elements of spaceflight. And then we have other times when we're waiting in between events to just be able to take in the view that we've got outside the window and float around and have fun. So it's a totally 100% fun environment as far as I'm concerned.
John, I have to tell you, I'm a big Michigan fan. I was excited to hear Michigan beating Notre Dame yesterday, but the biggest cheer here was when we got the Spyfex picture looking back at the shuttle, and I don't know if you saw that, but we let out a yell that the people at that Michigan game couldn't have yelled any louder than the six of us. So I agree with Dick. There's a great sense of accomplishment, and that's fun.
Jerry and Dick, thank you both. We're out of time. I have seen the SpyFX picture. We're going to share it with our viewers a little bit later. Thank you for joining us as well. It's John Holloman, CNN reporting.
Clear, Bill.
Well, thank you very much, gentlemen. I appreciate you taking time to talk to me tonight. For Commander Richards, I'll just jump right in if you don't mind. We haven't seen a lot of video on this flight from the orbiter, so it's been a bit tough for us on the ground to get a good feel for how the flight's been going. What sort of early report card or grade would you give STS-64 to this point anyway?
Well, from the light payload, I'll let Mark talk about that. We've predominantly doing light and SpyFX work, and I would say we get the most direct feedback from the SpyFX work, largely because it's almost all controlled on board, and we almost see the product before the ground does. And from what I can see, it looks very, very good. We encountered some early problems, but Susan Helms and Mark Lee were able to overcome all those things. And I think we're batting a scorecard now somewhere about 90 to 95% of all the planned data points we've successfully achieved. So from that perspective, I think things are going very well.
You mentioned you've had a few occasional problems with SpyFX and, of course, the high data rate recorder used by light. Are you satisfied, or from what you hear anyway, are you losing any significant data, or are you achieving, by the end of the flight, what you set out to achieve?
Well, it's hard to tell, Bill. From our standpoint, we're doing all of the onboard science gathering data that we can do. We're taking a lot of pictures every day past that we're awake. We have the camcorder running. We're taking pictures, and we're trying to characterize the atmosphere so that afterwards they can correlate the data with their ground sites and the filming we're doing on board. So from our standpoint, we're gathering all the data we possibly can. It's going very well. The high data rate recorder, you're going to have to get a reading from the ground on exactly what impact that's going to have.
Commander Richards, I know that you're all hoping this flight's going to be extended at least for one day anyway for additional science observations, but it's obviously going to be tight. Are you optimistic about getting the 10th day, and are you taking any unusual steps to conserve a watt here and there?
Oh, well, again, Mission Control is the folks that have this all plotted out, but our own informal plot, based on the morning mail we get, indicates we're gaining ground by about 2 hours every day. So that's provided encouragement that energy conservation methods on board the orbiter, we still got a shot at this thing. This is about the brightest the middeck has been in 3 days here, Bill. It was just for you. And for the most part, we've been running around here with flashlights and turning off lights and conserving every little bit of electricity that we possibly can in order to try to make this extension day. And I hope it happens. At least we're planning on some work during that period, and if we get it, that'll be great.
Question for Colonel Meade. If you don't get the extra day, does that impact your planned data collection? I mean, can you still meet all of your pre-launch objectives, at least at this point, as far as you can tell?
I'm not sure, Bill. Right now, I think we plan to do some SpyFX work on the last day. It would be unfortunate if we didn't get that, but we've got quite a bit of SpyFX data taken right now. I think about 85 out of a planned 90 points. So if we could squeeze those last couple of points in, we'd be real happy on the last day.
I'd like to shift gears for just a moment and look ahead to Friday's spacewalk, if I could. It's been 10 years since any shuttle astronauts carried out an untethered spacewalk, and at your crew news conference before launch, you both stuck to fairly technical descriptions of the test. You didn't really indicate any personal excitement over the prospect of floating free in space, and I'm just curious that now you're back in orbit, are either one of you getting at least a little bit excited about it?
Yeah, we were just commenting that we're all three of us floating free right now, so it's getting us a little bit closer to what we had in mind. I think I for one, haven't even thought much about the EVA. We've still got a lot of work to do between now and then. We've got a satellite to deploy and to retrieve. One wrong burn on that could change all of our plans. We're concentrating quite a bit on what we have to do in the next several days. Mark, do you have anything to add to that?
Well, Bill, I'm sleeping in the airlock every night, so I sit and look at the EMUs. Hope they're all working good, and so we're all ready to go on Friday. It's something I've been looking forward to ever since I've been in the astronaut office, and getting to do the untethered part is even an extra thrill. So I'm really looking forward to it. It's going to be a good time, and I think we're going to get great results from SAFER.
Hamid, you mentioned before launch that the psychological aspect of floating untethered in space outside of the shuttle has got to be a little bit different than when you're attached to a safety tether. I was wondering if you can expand on that just a little bit, and at the same time, I was curious as to what sorts of scenarios have been developed where an astronaut could get free of a safety tether inadvertently. I mean, as cautious as you guys are during EVAs, it's hard for me to imagine how it could happen in the first place.
Well, I'll answer the second question first. You know, an EVA is often described as 90% tether work. That's mostly what we do is play with tethers. You know, we tether tools, we tether people, we tether objects. And so it is, as you can imagine, with several hundred tether swaps during a typical EVA, you might think it'd be reasonable to expect someday for one of these tethers not to work so well, either by human error or by mechanical fault. As you may or may not know, our friends in Russia have already had this occur once, and somebody got loose in space and retrieved within a hand's grasp. So it's something that can happen, and I think fairly easily. As far as your first question is concerned, you know, all of flying is a mental game. It's rarely, or it's a minor physical impairment. It's mostly a mental. So mentally being prepared for something like this on the EVA is something that I think both of us are doing. We always think about all of this stuff and plan it through our minds, try to anticipate what's going to happen, and as long as you're mentally prepared for most of this stuff, I think it's going to work out okay.
For Commander Richards, and this is just curiosity on my part, the sort of scenario you're protecting against here, of course, is when the shuttle is docked to another vehicle and can't come to the rescue of an untethered astronaut. How long would it take to undock a shuttle in an emergency situation? I realize there's no exact answer to that, but I'm just curious. Is that an hour-long procedure or several hours, or how would that play out?
Well, I don't have much idea with that because I'm not all that familiar with the docking systems planned for Mir or for shuttle. Maybe Mark or Carl can field that question. I have a feeling it's not going to be in the time frame that we're talking about, because I know in the safer EVA, if someone starts floating off even at relatively slow rates of 1 foot per second, it doesn't take too much mathematics to figure out, particularly if it's dark, that the individual is going to float out of whatever floodlights you have in view, and once you lose sight of them, it's going to be very difficult to be able to find them again. So, but I can't answer it fully because I'm not that familiar with the undocking mechanisms for station and for a mirror.
That's okay. You just answered my question. One more on the spacewalk, and I'll address this one to Colonel Lee. I think there are something like 25 more shuttle missions between now and the start of space station construction, and of those flights, I think there are, at present anyway, about 8 spacewalks planned, or 8 missions with spacewalks planned. Is that going to be enough? I mean, to a layman, it would appear that NASA would want to do as many spacewalks as they could between now and then to gain experience. So I guess the question is NASA being a little bit too conservative in how they chart out their EVAs?
I don't think we're being real conservative. In fact, I think we're doing the right thing. We've done making every effort that we can to add spacewalks to flights that can accommodate them. So we understand that we have work to do. But you can do most of this training. I don't think there's going to be a lot of surprises for me on Friday. The water tank has proved to be a very reliable place to train. It gives you a good feel for what it's like to go on a spacewalk. So I think we've got the right training tools. We've used virtual reality. It's another added dimension. So in addition to the spacewalk, giving enough people a taste of EVA, that with our other training, I think we're gonna be ready. We're certainly looking forward to doing it.
Colonel Meade, I'd like to look ahead to tomorrow's launch of the Spartan satellite, of course. Just in your words anyway, what can Spartan do that can't be done by sounding rockets for the UV or by ground-based telescopes for visible light?
Spartan is carrying some ultraviolet instruments, which the ultraviolet does not reach through the atmosphere. And so most of the observations that Spartan is doing cannot be done from the Earth. It has to get above the atmosphere. And furthermore, they are engaged in some very, very fine pointing and accuracy requirements. And so all of those instruments have to be pointed in a manner which is very demanding. It's so demanding that it can't be done from the orbiter itself. So we deploy the satellite into space, and the satellite then has its own attitude control system with very fine RCS jets or reaction control jets, which point it very accurately. And so that's why we're actually deploying this thing out in outer space.
And Commander Richards, I suppose Spartan's especially interesting to you since you helped launch the Ulysses probe, and there are going to be some complementary observations made during this flight. Could you perhaps touch on how the two spacecraft are going to complement each other?
Well, Ulysses is near and dear to my heart as I worked very hard on that thing several years ago to make sure that it was deployed on time and accurately by the shuttle, and it's been one of NASA and ESA's success stories, out to Jupiter and back, and now crossing the south pole of the sun, and almost 100% in commission as it left the shuttle's payload bay. So I've always felt a fondness for Ulysses, and it's just personally exciting for me to just be playing a small part in support of Ulysses as it becomes the first object from Earth to cross the south pole of the sun. And I'm just hopeful that STS-64 is only 90% as successful as what Ulysses is, and if that's the case, it'd be a great mission.
Looking back to light for just one moment, it appears the light instrument obviously is working well. Does having an experiment like that on board the shuttle make any of you more conscious of Earth's environmental health than you might otherwise be from space, or is that something you're always attuned to in orbit?
I think everyone that comes up in space, the first time they look down at the Earth, and they see how small it is and how fragile it is, and they see, the pollution, the dust storms, the fires, that they can't help but come away with that a little bit changed by the experience. I certainly have been changed by the space flights and my appreciation for the environment, and I think almost everyone else is the same way.
For any of you, the light experiment and the Space Radar Lab flying again next month on Endeavour are both obviously technology demonstration payloads. There doesn't appear to be any money in the budget to build satellites based on that technology. What do you say to someone who said this is all a moot point? I mean, if you don't put one of these things in orbit all the time.
Well, there's naysayers all the time. So what we need to do is prove that this thing works. Already, light has proven that they can possibly detect storms that are developing. There's a lot of information that we can get from light and Shuttle Radar Lab. And once we get, that data and we show people what is possible, then I think the funding will come. But we just have to get through these technology demonstrations and then see what we can do with the data.
And a couple of quick questions to close this out. Looking at SpyFX, for those of us on the ground who watch rendezvous with things like LDEF or Intelsat, the shuttle comes in so slowly it's hard to imagine that the force of those maneuvering jets could actually cause damage to a space station like Mir when they occasionally can run a progress module into it. I'm just curious, it sounds like the forces that the SpyFX is measuring are less than what the math models had anticipated. Is that jibe with what you see out the window? I mean, in terms of the arm ever moving or anything like that?
Well, when you're talking about the plumes, you're not talking against metal against metal. You're talking plumes against solar rays and other flimsier structures. We've really watched the arm move. I mean, some of the shots out the front with some of the bigger jets have made the brakes slip in one occasion, and it's definitely, you can see the arm move. So it's a pretty good force. It's kind of scary to see those jets fire and see them hit the arm and make it move. So we're definitely worried about the forces that it could input to a structure up in space.
Well, then let me just follow that for one moment. Is that something that, looking out the window, you didn't expect to see that happen, or do you think this is still in line with something you can handle when it comes time to dock with Mir?
Well, I'll speak for the SpyFX people here. I guess when you put the SpyFX boom in some of the locations that are of close proximity to these big jets, and of course we've always had respect for them because when they fire, they send a shudder throughout the, particularly the primary jets, send a shudder throughout the orbiter structure, particularly on the forward end, which is the ones we're closest to. And so we've always known that they've got packed quite a wallop. And our observations from the windows here, as Mark has stated, show that there is a force being imparted. There are, from the piloting side of it, I've been participating in some of the docking exercises that we've been doing up and leading up to this particular test. And there are methods to work around this. What we really need to do is just better understand what the forces are, and then we'll have to combine engineering, design, along with operational procedures, much as we do anything in the space program, to try to stay within the margins of the structure that we have to rendezvous with.
Time. Last question for Mark. In passing, you launched Magellan 5 or 6 years ago, and it's getting ready to go back into the atmosphere of Venus. I wonder if you had any thoughts about that, and that's my last question.
Well, I'm much the same way about Magellan that Dick is about Ulysses. I mean, it's been a great satellite. We worked with JPL. They did a real good job of developing a mission. It worked out successfully. So, I feel pretty much the same way. I'm really proud of that satellite and my association with it.
Thank you, gentlemen. Have a safe flight back. Houston, this is Space News. That concludes the event.
WBBM News Time, 12:22. I am pleased to report the technical difficulties were on our end here on Earth at WBBM. Nothing, no problems with NASA or the Space Shuttle Discovery. Joining me from orbit, Colonel Blaine Hammond Jr., pilot of this mission specialist, Colonel Carl J. Meade, and Lieutenant Colonel Susan J. Helms. Welcome to WBBM News Radio 78, and how's the mission going so far?
Well, thank you. The mission's going great. We're having a great time up here, and we're real proud of the science we're getting so far, and looking forward to the rest of the work we have in front of us.
Colonel Hammond, you are about 140 nautical miles above the Earth. What part of this little blue planet are you over right now?
Stand by. We'll have to ask upstairs. That's where our map is.
Okay. While you're doing that, let me ask for your reaction to putting in some overtime on this mission. Your mission has been extended for one more day in orbit. What is the reaction?
I think elation on all 6 crew members. We were hoping from the start we'd get the extra day, and it's been touch and go, as you know. But we were informed this morning that we did get the extra day, and we're all ecstatic to have that for science and for an extra day in space.
Very good. Colonel Meade, you and mission specialist Mark Lee will be taking a spacewalk on this mission. It's called Safer, Simplified Aid for Extravehicular Activity Rescue. The future building of a space station in orbit and the future of performing other scientific and commercial work in space will be crucial for individual astronauts to be able to freely maneuver outside a shuttle or other vehicle, whether to perform the work or to rescue an object or person. Colonel, what are your thoughts about your upcoming experiments using this self-contained backpack propulsion device?
Well, this device is not actually used to maneuver an EVA crew member. The device will be used only in a rescue. It doesn't have the performance capability that the earlier version of this device called a man maneuvering unit had. So that this one will be simply a test run of the device to make sure that it's adequate for the job of rescuing an adrift EVA crew member.
It's a very crucial experiment. Your thoughts about going out there? You can practice so much on Earth, but when you actually get out there, it's the real thing.
Yeah, I think that most of our thoughts are centered around just performing the tasks, thinking about what we have to do, trying to anticipate any problems we may have. I think I've said before that most of this type of activity is a mental problem, not a physical one. So we all try to become mentally prepared and determine exactly anticipation, what we're going to do, and what's going to happen in the flight. So I think although we're excited and anxious to get out and do the job, once we get out there, I think you'll see that most of it's going to be pretty cut and dry and just a professional walk right through the numbers.
You're listening to WBBM News Radio 78. I'm talking on the air from orbit with the Lieutenant Colonel Susan J. Helms, Colonel Carl J. Meade, and Colonel Blaine Hammond Jr., the 3 of the 6 members of the Space Shuttle Discovery now in their 9-day mission. It's been extended for 1 day. Lieutenant Colonel Helms, you helped deploy a satellite on a previous mission, and in a couple of hours, the Discovery crew will be placing into orbit a special satellite, Spartan 201, to study the sun and the solar winds that can have a velocity of 1 million miles an hour. What is the importance of knowing more about those solar activities?
Well, I think that as we on the planet become more and more involved with communications from space, we're beginning to realize that there's a lot off of our planet out here in the void of space that does have an impact on how we live on Earth. For example, sometimes when you see problem the solar flare activity or other activities going on in the sun. So we need to better characterize what's happening with the sun so that we can better understand how to live on Earth. And the great thing about the Spartan is that it's going to measure exactly that. It's going to measure the south pole of the sun this time. It had a very successful mission on STS-56. We're going to continue the overall objectives of that mission by measuring a different part of the sun's corona, and by doing that, measuring the science and characteristics of the solar activity off of the sun, off of the surface of the pole. We're going to better understand how to build the satellites and other objects we plan to put into space so we can better our life on Earth.
The physics are a little bit different, perhaps, when you hear of a velocity of 1,000,000 miles an hour with a solar wind. You think that could be quite a headwind for the shuttle to be facing, but it's a little different out there in space.
Well, in truth, we don't actually see it or feel it, but we know it's out there based on the fact that we do get those occasional interrupts on Earth in our satellite feeds.
Let me address the next question, if I may, to Colonel Hammond. Colonel, 2 days after the satellite is released into orbit, you'll have to maneuver the shuttle to within a few hundred feet of the Spartan 201. Is this an especially difficult maneuver, and are you operating under visual flight rules?
Well, let's see. It is difficult, but Dick and I have a tremendous amount of training to learn to do this, and Dick will actually be doing the flying of this. I'll be in the forward portion of the cockpit doing the maneuvering and the computing the targets, but we've had a lot of simulator time on this, and it will be all visual from several hundred, almost a couple thousand feet in, and Dick will just be maneuvering based on some inputs from lasers, laser trackers, a radar, and visual cameras.
During this mission, you'll briefly be talking by amateur radio with students at 10 schools around the country, including the Crystal Lake South Elementary School in the Chicago suburb of Crystal Lake. Do you find that many students are interested in the space program, and do they have realistic or unrealistic perceptions, perhaps tainted by Star Wars, Star Trek, or other popular science fiction?
Well, we've all been participating in SARX. Jerry, myself, and Dick have our licenses, but we've had tremendous reception with SARX in the schools. The children are more than just fantasized by space. They really have intelligent questions, and I'm sure a lot of that is prompted from their teachers and their parents, but their questions are well thought out, they're well prepared, and we hope we give them the right answers and the things that they want to hear so they can learn more about it. But they seem very naturally inquisitive and looking towards reality rather than just a fantasy.
Are there any particular questions you frequently hear from the students when you do these kind of interviews, either from orbit now or when you're on the ground and meeting with students?
Well, they always want to know how do we go to the bathroom up here, and that's one we try to avoid. But they like to know how we eat and what's it feel like. That's a big question. What's it feel like to float free? As you can see, we're kind of floating here, and it can be both fun and a hindrance at times. They want to know what it looks like and what happens if we run into something. I think that's been a fairly common question. How do we avoid objects in space? Because I guess they've heard that there's a lot of debris out in orbit. So. But again, like I said before, the questions are extremely intelligent, and we've been real proud of the response we've got.
You're listening to WBBM News Radio 78. I'm talking on the air live with Colonel Blaine Hammond, Jr., who is piloting the Space Shuttle Discovery, and mission specialists Colonel Carl J. Meade and Lieutenant Colonel Susan J. Helms. Another one of the many interesting experiments on this particular mission uses a laser beamed from the shuttle toward the Earth to help us understand more about the climate. Has that particular experiment already been underway, and if so, how is it going at this point?
Yeah, that experiment has been ongoing since the very first day of the mission, as a matter of fact. We run the experiment about 8 hours a day, and during the downtime, we allow the scientists to look at the data. They have been reporting very, very favorable data coming off of the experiment. They are ecstatic with the results they saw over one of the tropical storms. I think it was Debbie. So I think we've gotten some good data out of the experiment, and there are probably going to be more good data to come.
In terms of space missions, there are several old hands on board. Commander Dick Richards now is flying his 4th mission, and 5 of the 6 crew members have had at least one prior flight. Is there still a sense of awe, excitement, or inspiration for everyone on board a flight like this?
Absolutely. I've never heard so many ooh-ahs and wow, look at this, and awesome and all kinds of expressions that you can conjure up, but it's absolutely fantastic to be back up here again. The view is just incredible. It's unfortunate we can't spend all our time in the window, but obviously we have a lot of work to do. But every free chance we get, there's about 5 or 6 noses pressed up against the glass someplace at some time.
It used to be for shipboard passengers that there'd be an initiation ceremony when you crossed the equator for the first time. Are there any unofficial rites of passage for rookie astronauts on the shuttle mission, and has your one rookie astronaut been subjected to that already?
I think just getting in space and learning how to use the all the facilities on board here is initiation enough, and maybe Susan has a comment on that.
Yeah, now the only thing we did that was special for Jerry was as we were going through the launch sequence and we were climbing up above 300,000 feet, right after that we hit 50 nautical miles above the Earth's surface, and whenever there's a rookie on board, we all yell, "Congratulations," because that means that Jerry, at that point in time, is a real live astronaut.
How much work is involved on a typical workday on board the shuttle? People on the ground may see little snippets of the TV video coverage, or they might do an interview like this for 10 or 15 minutes, but it's more than just a 9-to-5 job when you're in orbit.
That's exactly right. We're actually on duty from the time we wake up until the time we go to sleep, so it's about a 16-hour day, but we have a couple hours at each end protected to help us get ready for sleep and get cleaned up and fix meals. But for the most part, there are a lot of housekeeping duties. Things are not as easy to do up here as they are in one gravity on Earth, and it takes a lot more time to get things set up. And finding things, locating them in the lockers, and getting everything set up to the science and everything stowed away neatly and out of the way, it takes a lot of time and just a lot of, it's just what we'd call a time sink up here. But there is our days are quite packed with activities, and like I said earlier, we treasure every spare minute we have to look out the windows because there doesn't seem to be a whole lot of that these days.
Okay. There's quite a bit of housekeeping involved. You're following the flight log as closely as possible, but things always come up during the mission.
Well, that's true. You're talking right now to sink and housekeeping ops here. I do the vacuum cleaning. I do the trash compactor, taking care of a lot of the housekeeping downstairs. But everybody pitches in and make sure the ship is neat and tidy and everything's ship shape. You just can't let things get out of hand up here. So you can see cables get out of hand, things float around. You lose things, and then sure enough, a few days later you'll finally find them, but maybe not where you expected to. So yeah, everybody has to pitch in.
We have about a minute left. This could be called a Midwest mission. Half the crew comes from the heartland. There are 2 crew members from Missouri. You've got a Wisconsin native on board. Has this geographical heritage played any role in onboard conversations, such as perhaps sports rivalries over the weekend?
Oh, sure. We keep getting sports reports, and we try to make special time to look out the windows when we come across the heartland of the United States. But we're all Americans, and we all look forward to any time we come across the U.S., and any time we get a pass where it's clear weather, we're out taking shots and looking down at the Earth and admiring our country.
Colonels Hammond, Helms, and Meade, any last thoughts in our interview now? Leave with the people of the Chicago area about this particular space mission or the future of the space program in the United States?
Well, I guess up here we've been very, very excited to have so many different kinds of activities on this space shuttle mission because we know that we're participating in a lot of different areas in a lot of different ways with our particular mission. And in light of that, we would like to thank all of you for giving us your support. We have really enjoyed what we've been hearing from Earth and all the help we've gotten from Mission Control in particular. And we're getting as many great shots of the United States as we can, and every time we go of it, we think of all of you down there, and hope everything's going well with you, because it certainly is going well up here.
Okay, Discovery, this is WJR. Joel and Dana certainly sending our congratulations to you at this point in the mission, and big hellos from the Motor City.
Especially to Commander Jerry Lininger. Commander, you've certainly made us proud and happy, all the folks in East Point and everyone across Michigan, because of your participation in this mission. Is space everything you expected it to be?
It definitely is everything I expected. It's that and more. The liftoff was just spectacular, and I think to the people that came to the launch, it was more than they expected. And people were, from what I understand, just full of tears and joy and jumping up and down. And we had about 500 people from the Detroit area
Yeah, Commander, we know that you participate in endurance events like triathlons and marathons, but what's this endurance event called STS-64 like?
It's quite a bit simpler moving around up here than it is down on Earth, but I got to tell you, the other night we have a new extended duration orbiter treadmill that we're testing out, and I decided I wanted to run around the world, so I stayed on the treadmill for 90 minutes, which took us one orbit around the Earth, so that was my new endurance record in space.
Commander, your mission has been extended by a day. You now will return on Monday. Why?
Well, all along we planned on trying to get a 10-day mission out of it, but our power allocation was low, and so we've been conserving power quite a bit, and we've done well at that, and so we're able to get an extra day out of the mission, and that means we can accomplish more up here during that time.
Okay, Jerry, well, good luck to you. Colonel Lee, we'd like to ask you a question about one of those activities. This is your second trip aboard a space shuttle, and this time you're going to get to go outside, but wait a minute, there are no strings attached. Tell us about the Jetpack EVA, would you?
Well, today was a big day for us. It's EMU checkout today, so we checked out the spacesuits. We powered up Safer. It's working just fine. So it's starting to look like we're actually going to do this on Friday. We're starting to get pumped up about it.
Colonel, how do these packs differ from the jetpacks that the shuttle crew used back in 1984?
Well, they're quite a bit different in design and also purpose. The MMU was designed to, go greater distances, go work on satellites, bring them back to the payload bay. It was also much bigger. It weighed almost 500 pounds. This unit only weighs about 80 pounds. Has a much smaller Delta V capability or, consumable that it has on board. So it's more of a life preserver than anything else. When we have shuttle dock to Mir or when we have a space station, it'll be our safety pack in the event that somebody becomes detached, allows them to get back to structure when the shuttle can't come and get them.
Now, there certainly is going to be an element of risk when you try them out on Friday, but you have practiced maneuvers in order to eliminate most of that risk, but my palms are sweaty just thinking about you guys out there. How do you feel about it?
Well, I'm not really nervous. We train for lots of different things up here, and we get up and we find, a few things that are different, but basically what we expect is there. So we're hoping everything goes fine. I'm sure I'll be a little bit more nervous that day than I am today, but we're ready to do it.
Well, you guys look wonderful on television, and you sound good to our listeners here in Detroit. I only wish that we could hear a little bit of Max Q. It's a rock and roll band, and their keyboardist happens to be sitting next to you, Colonel. She's Lieutenant Colonel Susan Helms. Colonel Helms, do you miss the rock group? Have you spoken to them since you've took off last weekend?
Well, I'm afraid that none of the members of the band are serving in mission control for this particular mission. I have written a note to our lead singer asking when our next gig is. I understand that about 4 days after we land, we're going to be having a gig in the local area, and I'll be playing for my own post-landing party in Houston. In any case, I do miss the band. I know that as soon as I get back, I'm going to have to get right back and practice again because it looks like the band's really going places, and we're pleased about that.
What a Renaissance woman. Well, women in space are certainly routine now, but you're still very much a pioneer, and there are a lot of little girls who might not think too much about math and science because they don't know where it might lead them. You're a perfect example. What advice would you give to young girls who aspire to do what you do?
Well, the first thing I would say is to let those young girls right now learn that nobody should stop them from doing what they want to do. I think one of the things that made me get where I am today is the fact that everywhere I went, I had support from everyone that was around me, including my science teachers and my parents and other adults that told me that if I wanted to go after something, I should go for it. And the young women today who are in that position should have the same attitude, and that will make all the difference in the world.
All right. Well, that's very well stated, and we heartily agree with you, too. Thanks, Colonel. Another colonel on board is the pilot, or at least one of the pilots, of this particular space shuttle mission. and he is Blaine Hammond, a colonel with the U.S. Air Force and a NASA astronaut as well. This is your second time in space, isn't that right, Colonel?
No, that's right. I was my last flight was STS 39,
And how does the Mission 64 compare with that one way back in 39?
Well, they're both long missions. 39 was 8 days. This will be a 10 days, so I'm looking forward to the extra 2 days. On 39, we work shifts, so we had 2 shifts going around the clock. Here it's a little bit more routine in that we all pretty much eat at the same time and go to bed at the same time, but it's a little more crowded in that respect because whereas you have 7 people split in half, now we've got all 6 people at the same time, and as you can see, putting 4 of us in a small space is pretty crowded here enough, but you put 6 of us on the flight deck when we come across a good Earth viewing pass, it gets really crowded, and there's not quite enough window space to accommodate everybody.
Colonel, we have...
we call that a photo frenzy when it gets up there like that.
Colonel, we have a lot of pilots that are listeners. Joel's a fixed-wing and a helicopter pilot, and we have a lot of pilots that are listeners. Give them a vicarious thrill. Tell them what it's like to take that shuttle into orbit.
Well, Jerry expressed it as riding a herd of buffaloes. I think I could probably agree with that. I liken it to probably a high-speed Mack truck going off the pad there. It's really exhilarating. The engines come up, everything rattles and rumbles, and next thing you know, it counts down to 0, and it's just like the world drops away from you. And there's nothing more exciting than that. I've flown all kinds of fighters and airplanes and helicopters too, and they're all thrilling in their own way, but there's nothing like that lift off in the pad. That next 8 minutes is a ride like you can take every best ride at any amusement park, I think we'll all agree, and there's just nothing like it.
And Colonel, on the other end of the mission, of course, is your return to Earth through the atmosphere. So much for acceleration when you leave the launch pad. What's it like coming back down to the atmosphere? Can you actually feel it pulling against you as you slow down at tremendous rates?
Actually, the deceleration is so gradual, but on the other hand, you've been used to 0 gravity for so long, just a little bit of gravity really feels like a lot. And by the time you get back to just single gravity, you really feel heavy and cumbersome. It was quite amazing to me on 39. I'm sure I'll feel it again on 64. Just the fact of getting back into Earth's gravity will be real weighty, and it'll take takes about a day and a half to really get accommodated back to normal gravity. But there's not really all that much deceleration that you can feel. We pull only maybe a G1.5, 1.8 or so at the max, maybe just before we land. But it's very, very benign. I was really kind of surprised on 39 that it was as benign as that. Although, like I said, even just a little G seems to feel like a lot.
Well, this is a question for any of you or all of you. The guys and women down in Houston seem to get real pleasure out of waking you up every morning with different kinds of music. Do they really wake you up, or do you have little travel alarms up there?
Well, we pretty much sleep right until we hear the songs go off. Most of us have our watches set or something, so I think we wake up pretty much at the same time. But we're ready to go to bed, and we sleep a full 8 hours up here for the most part. And space flight, though it looks like a lot of fun, it's very fatiguing, and there's a lot of mental stress, learning how to cope with new environment, and simple tasks like just filling a bag full of water seem to take twice as long as you'd expect it to. And maybe Jerry can fill you in more on that since he's the rookie here.
Okay, Mr. Rookie, another orbit, another sunrise. That's kind of the way it works up there every 90 minutes. We know that you're going to be looking at another sunrise here, too, momentarily as you come over the Indian Ocean and pass over Australia momentarily. We wish Godspeed and good luck to all of you. And one final question here from Dana before we say goodbye from Detroit.
I assume you've heard that there's no more baseball for the rest of the season. Any disappointed baseball fans up there?
I got to comment, being a Tiger fan, the way the Tigers were sitting, I wasn't too disappointed to see that one come to the end. I'm glad to see University of Michigan starting to kick in already.
That's cold, Jerry. That's real cold.
Hail to the victors, and thanks very much to you, Commander Lininger. It was a pleasure speaking with you, Colonel Lee, Lieutenant Colonel Helms, and also to you, too, Colonel Hammond. Say good luck to the rest of the crew for us, and we'll be pulling for you from down here.
Godspeed.
Good luck. Thank you very much. And that concludes our interview.
Thanks very much. It was a real pleasure talking with you all. Thanks a lot.
This is a CBS News special report, a conversation with the Shuttle Discovery crew. I'm Frank Sedapani in New York. Let's begin with some introductions now. The three crew members we know we'll be hearing from are Navy Captain and Mission Commander Dick Richards, Mission Specialist Jerry Leninger, a Navy Commander, and Mission Specialist and Air Force Colonel Carl Meade. We may be joined later on by Air Force Lieutenant Colonel Susan Helms and Air Force Colonel Mark Lee. What we would like to do is go around the crew now and have each crew member who is available introduce himself, or if Lieutenant Colonel Helms is there, herself, so that our listeners can get some sense of their voices. So if you would begin, please, Captain Richards.
Well, this is Captain Dick Richards. As you said, I'm the mission commander for STS-50, and unfortunately we'll only have three crew members today, myself, Jerry Leninger, and Carl Meade. I'll let Jerry introduce himself.
Hi, I'm Jerry Leninger, Navy Commander and a physician, and this is my first flight, so I'm, I guess, the rookie on the flight.
Okay, Discovery, one more, please.
And I'm Carl Meade, an Air Force Colonel. This is my third flight. I'm a former test pilot.
All right, that out of the way, let's begin with Captain Richards. This was scheduled today to be a bonus day when your flight was extended. What have you been doing to keep that crew of yours busy up there?
Well, today was supposed to be SPIFEX day. We were supposed to complete the test points on that particular experiment. We started out in that direction, but we've sort of been in a hold here for the last hour or so while we sort out a few things on the ground. So we've had a respite here. And later on, however, regardless of the outcome of the SPIFEX troubleshooting, we're going to proceed with our primary payload, which is the light payload, and complete its mission objectives.
Now, Captain, for some of our listeners who may not be familiar with the terminology, could you explain what it was that you were hoping to do today?
Well, the primary objective, the real reason for the extension day is to get some more test points for the LIGHT experiment, which is LiDAR in Space Technology experiment. And it is a laser. It is one of the first lasers we've had in space. It's been operating here on low Earth orbit in a research experiment and also an operational experiment to see whether or not laser technology will add to the complement of spacecraft we have in low Earth orbit towards viewing the planet, characterizing the atmosphere of the planet. And it has, a lot of the data is on the ground. We merely control and manipulate the orbiter and point it in the right direction here. But from what we've heard from our friends in Houston and at Langley Research Center, this experiment seems to be going very well, and looks like it may have significant applications for the future toward better understanding our environment.
You've also been doing some work on shuttle exhaust emissions, have you not? Could you update that for us?
Carl has been doing a lot of that. That'd be appropriate for him to explain that. Carl?
Yes, we have. We've been running an experiment which we call SPIFEX, which characterizes the plumes to which are emitted from the jet reactions that we fire to control our attitude on orbit. As you know, the spacecraft would drift aimlessly without these little jet firings that control its attitude, and so as these things fire, it emits an exhaust plume, the characteristics of which we don't exactly know. Now, it's important that we find out what these characteristics are, because when we come in close proximity to other spacecraft, be it satellites or possibly an orbiting space station, which we'll build in the near future, or the Mir space station, which we will definitely, that's the Russian space station, which we'll be docking to next year, we need to know exactly what these plumes will do to that object. So far, we've been able to compensate for that, the lack of knowledge, by operational workarounds. However, as the space station era evolves, the space station is so large that we're sure that the plumes will affect it. Therefore, we have to characterize the amount of pressure that is put out by the gas particles.
Colonel Meade, I'd like to return to you in a minute or two and get into that spacewalk yesterday, but first I have a question for Navy Commander Leninger. As you mentioned, you're a space rookie, and as you mentioned, you have a medical degree. Please tell me your first impressions of being in space, both as a first-timer and as someone with a medical background.
timer is just, an incredible opportunity up here. It's an incredible thrill, the liftoff, and adapting to space is an experience that I didn't think would come quite as easily as it did come. As a medical physician, I guess the thing that I'm amazed at, and I keep being amazed at this, is the adaptability of the human body. And after about 3 days up here, it feels like this is where you belong. And I think by the time I get back to Earth, when I try to walk, it's not going to feel natural anymore. So the human body is a tremendously adaptable organism.
In a minute or two and get into that spacewalk yesterday, but first I have a question for Navy Commander Leninger. As you mentioned, you're a space rookie, and as you mentioned, you have a medical degree. Please tell me your first impressions of being in space, both as a first-timer and as someone with a medical background.
As a first-timer, it's just, an incredible opportunity up here. It's an incredible thrill, the liftoff, and adapting to space is an experience that I didn't think would come quite as easily as it did come. As a medical physician, I guess the thing that I'm amazed at, and I keep being amazed at this, is the adaptability of the human body. And after about 3 days up here, it feels like this is where you belong. And I think by the time I get back to Earth, when I try to walk, it's not going to feel natural anymore. So the human body is a tremendously adaptable organism, and that's, just an amazing thing I've noticed up there.
Based on what you've heard and what you know from past experience, do you expect any problems when you get back to Earth? Just routine little things like headaches or colds or anything like that?
I don't expect that. There are a few things. Of course, up here in weightlessness, we're just kind of floating around, and so musculoskeletal system doesn't get the type of stresses that it gets down on Earth. To counteract that, for example, this morning I ran on the treadmill for an hour. We've got a new extended duration orbiter treadmill that you almost feel like you're back on Earth taking a jog. And so if we do some of these countermeasures, I think when we get back we'll have less and less problems. And that's especially applicable with long-duration missions that will come up in the future.
I know you were following yesterday's EVA, the untethered spacewalk, using those clip-on jetpacks with great interest. And some people who were listening in seemed to detect a healthy touch of envy in your voice when you spoke to Mark Lee, who was out there. Describe your impressions about seeing that.
Well, it was Mark and Carl both out there, and I'll tell you, it was absolutely phenomenal, and I don't have the words to describe it. They're out there by themselves, the human satellite, basically, with the Earth rising behind them and sunrise behind them, and it was just absolutely incredible. And I was inside trying to concentrate on the job I had, and that is kind of choreography for that event. But it was absolutely fantastic, and there's no doubt when a human being is out there, we can all relate to that. And when you look out and see Carl and Mark, it was just fabulous, absolutely tremendous.
Colonel Meade, you along with Mark Lee took part in the spacewalk without the umbilical cord, something only 6 others have done, and no one in 10 years. And you spent 7 hours out there. In a moment, I'd like to get into the mechanics, but first tell me, what was it like? What did you feel and experience?
Well, that's a bit of a difficult question. I suppose it was what I expected to begin with. The view outside is a little bit better than the view inside, since the structure here is quite extensive. Other than that, the darkness of space is something that really jumps out at you when you're outside the cabin. When the sun sets, it sets very, very abruptly, and all of the shadows, the only lights given are those of the orbiter. There's no other references. And so in that respect, it's a little bit strange, a little bit disorienting, I might say. But other than that, I think we've been practicing this EVA for about 6 months, and Mark and I both had a pretty good understanding of what was going to happen and anticipation of what was going to happen. So actually it felt quite normal outside.
Give me a run-through of what you did step by step. Briefly, please. Just explain what it was that you did and the steps that you ran through.
Okay. The entire activity yesterday centered around the unit we call SAFER, which is a little simplified aid that stands for a simplified aid for EVA rescue. And as the name implies, it's a rescue device to be used by an astronaut in case he becomes detached from either the space station or the orbiter if the orbiter can't chase him down. So we usually are tethered. Again, if you become detached by accident, then you would engage the device, turn it on, and fly back to the structure. It's a similar concept to using a parachute in an airplane. So if the airplane is disabled, you just jump out and use the parachute to get back. It's theoretically a one-time use device, very similar to a parachute. Yesterday was the first flight of it, so we did a basic flight test evaluation, what most of the test community would recognize as a performance evaluation and a flying qualities evaluation. That's how well it handles in relation to the human being. And then a systems evaluation, how well can you do the job it was designed to do. We did that in 3 phases, and Mark flew the first set of 3 hours, and then I flew that second set and just duplicated the test points which were done. So we have 2 data points, basically. So when we first went out the door, I spent all of my time setting up the payload bay for those tests while Mark was setting up some things, and eventually he simply started flying the test points. And his first thing that he flew was a handling evaluation and a familiarization. And then he flew an engineering performance. How fast can it go? How much thrust does it have? What are the moments of inertia? Engineering parameters, which we had to determine. When that was complete, then we evaluated its flying qualities. How well could we control its attitude and get close to an object or far away or speed up or perceive any changes? And then when that was over, we judged how well we thought it could do its intended job, which is to save somebody, very quickly reacting to a tumble situation, stopping the tumble, and flying back towards the orbiter. So that was the basic rundown of the entire EVA. That took about 6.5, 7 hours. We did a couple other things besides SAFER, but they were thrown in as time permitted.
Tell me about that tumble. Did you give him perhaps a little bit extra push there?
Well, I didn't mean to give him an extra push. He's a pretty big boy, though, and I've been practicing on the ground and in the water. We practice in a water tank, and it takes a lot of force in the water tank. So I gave him what I thought was maybe a tenth of that force, and it was too much.
Tell me what the sensation is like when you fire one of those things. What does it do to you?
You know, after you've been in space for 7 or 8 days like we have been, and we're very used to floating around and reacting our forces off of the panels in the orbiter, etc., it is unusual to have a machine on that will actually stop you in space. And so it is a different sensation. It's very similar to being on Earth. You know, nothing moves on Earth unless you push on it. But it is amazing how the human body adapts to space so readily. And then when you have a machine on that you can actually control your movements, it is a different sensation. So physically, it's not much of a force, but of course up here you don't need much of a force to get going. The surprising part about it was we could hear the jets firing, the little nitrogen-powered jets, there are 24 of them all over this device and pointing in different directions. And when they fired, you could actually hear them through the spacesuit.
And tell me about the weight of that. It's my understanding that the weight of these is much less than the old units that, say, Bruce McCandless used when he went out in '84.
That's right. This is a much simpler unit. It weighs about 80 pounds. The first unit that Bruce used was called a Man Maneuvering Unit, an MMU. It weighed about 500 pounds. However, again, the Man Maneuvering Unit was a different item, and it was used for a different purpose. This is a rescue device. It has no redundancy. It has limited amount of fuel and limited amount of battery power, electrical power. Whereas the one that we used earlier, 10 years ago, had dual redundancy in almost all of its systems. It had 2 hand controllers, a rotational hand controller and a translational hand controller. We only had one of those controllers, and we had to flip a switch to tell the controller what mode it was supposed to be in at any given time. So it's a much simpler system as compared to the earlier Man Maneuvering Unit.
Captain Richards, perhaps one final question. We have less than a minute. You were standing by in case something went really wrong with that EVA yesterday. What were your thoughts?
the reason that this safer unit was possible and to be built was the fact that, like Carl pointed out, is the fact that there was very little redundancy in it, so therefore it couldn't suffer very many failures. And so myself and Susan Helms and Jerry Lininger and Blaine Hammond were all at the ready inside the cockpit in the event that they got into trouble. Our first bit of relief came on Mark's first flight of it, which showed us that there wasn't anything inherently wrong with the closed-loop control system and that Mark had an easy time controlling it. With that, we sort of started, and as the spacewalk went along, we started crossing off things that could go wrong until we were left with just these little single-point failures, which could always occur. So we were always maintained, I think, a heightened degree of readiness in the event that they got in trouble. But we managed to enjoy the EVA at the same time, given as the more time it went along, just because we got more and more confidence in the unit itself.
Captain, thank you very much, and good luck to you and your crew on the flight back home. Houston, this is CBS Radio. This concludes the event.
Discovery, this is JSC PAO. How do you hear me?
JSC PAO, Discovery, you're loud and clear. How else?
You're loud and clear also. Do you have an opening statement?
Well, we're just very, I said many months ago when I first got assigned to STS-64 and our crew assembled in an office in the corner of Building 4 South there at the Johnson Space Center, we had a calendar that was 6 months into the future, showing almost the last date of September 9th. And we wrote down all of our integrated simulations, all of the milestones, the KSC tests. And I said then, and I said when we flew in for dry count and our practice launch count, dry count, PCDT, and for our launch counts, we'd never taken an eraser to it. And so far that eraser is still clean. It's the cleanest thing in our office. And this flight has gone much like our pre-launch schedule. Everything has been on time. We've achieved all of our objectives and even more than 100% of our objectives. So I think all of us, you're going to see 6 smiling faces here. You couldn't have asked for a better flight to be on, just from the payload complement, the team we worked with, and the success that we've achieved. So we're feeling very proud of ourselves right now and proud of the team that put this whole flight together. And we've still got 2 days left to go, and we want to make sure those 2 days are just as successful as the previous 9, but we're ready to do that.
Okay, we'll take questions. Mark?
Good morning. This is Mark Carreau of the Houston Chronicle. And I'd like to ask one of you who's seen the light laser operate to paint kind of a word picture of what it looks like to see this thing. Can you see the light come out? Does it go down through the atmosphere? Can you see it splash against the clouds?
Well, you can't see it against the clouds. We've been looking real hard for it. What you can see earlier in the mission when the moon wasn't out, as the laser comes out, it comes out 90 degree perpendicular to where it exits the payload bay. And there's a green shimmering around the pallet and around the arm that we saw. And other than that, the only time we've seen is when we've been doing some maneuvers. We've been doing these cross-tack maneuvers where we fire a number of jets, and the particles that come out from the jets about, I'm guessing 100 to 500 feet out from the orbiter, you can see the pencil-thin green beam going through those particles. So that's the only time we see it at all. Other than that, it's been, the instrument has worked real well.
This is Mark Carreau again with a second question for Carl Meade. Could you give us an idea of what you might be telling your colleagues about the safer mechanism? Did you feel that your experience would justify a recommendation for producing something like this for use by the space station colleagues?
Well, without sitting down and giving it some serious thought and reviewing the tapes and all the data, I hesitate right now to give a recommendation. However, my first impression of the device is that it was very satisfactory and was adequate to fly and had good handling qualities, so I think the recommendation is going to be very favorable. However, I'm going to hedge my bets a little bit before I review all the data.
Discovery, please stand by for KSC PAO.
Discovery, this is KSC PAO. How do you hear me?
Loud and clear, KSC.
This is Marcia Dunn with the Associated Press for Mark Lee. Could you describe, please, how it felt to be a human satellite?
Well, basically, it felt real good. There was really two aspects of it. One is when you're at night, where the total blackness of space just overwhelms you when you don't see the shuttle. That part was probably, the scariest of the whole part is when, you're rotated, you're tumbled, and all of a sudden you see black, and you just hope you keep rotating, and you hope that the shuttle shows up again when you come around. And then flying during the day was really spectacular on the precision flight eval, where we're in an attitude that you look off to the horizon. It's like flying, out all by yourself. I kept glancing over at the arm to make sure it was still there. So there's a mix between having to concentrate, very hard on maneuvers to make sure you do them right, because you only have one opportunity, and the exhilaration of seeing some sights that I'm probably never going to see again or never experience. So it was really a special treat.
This is Beth Dickey with Reuters for Carl Meade. I sensed a little bit of reservation in your voice about recommending the SAFER. Is that true? Do you think that there needs to be more test flights before that unit is turned into an operational system?
No. I hope you don't misinterpret my comments. There's no hesitation in my voice at whatsoever. It's just I usually don't make recommendations like this while I'm still in flight. I'm used to actually sitting down and analyzing the data and going through it very, very thoroughly. So that's just my technique. But there's no hesitation in my voice.
This is Todd Halverson of Florida Today for either Mark Lee and or Carl Meade. You've both flown in space 3 times now, and now you've both done untethered spacewalks. I'm wondering how you're going to top that. What you want to go after next in terms of mission?
Well, we're going to arm wrestle later today for the landing. Now, what I'd like to do, my goal has always been since I got there, was to help build the space station. And I hope that we stay on schedule now, and I'm able to take part in that. I think it's quite a thrill to fly untethered, to look at the Earth, but to come up to a space station and work on that is one of my goals, and I hope that works out.
This is Phil Chen, Earth News. We realize the efforts you've been going to save power, and that apparently the PAO events are the only times you have all the lights on in the cabin. What's it like floating around in a dark crew cabin with just a little flashlight groping your way around?
Well, being my first flight, it seems very normal to me. It really hasn't been too much of a problem. We usually have a light on indirectly, and on the flight deck when it is nighttime, it's just so spectacularly beautiful outside that the darkened ship is kind of nice because your eyes adjust. So it hasn't been a terrible sort of thing, and we've been getting along just fine.
This is Joel Powell of Space Information Canada and Countdown Magazine. For Susan Helms, could you just comment on the RMS ops with the Spartan satellite? Was there any problems with it? How the satellite functions during the mission?
Okay, well, I can answer the second part first. We don't know yet how the satellite functions because all of the data is still on board the Spartan, and we have to wait until we return back to Earth so we can open it up and see what's inside the recorders. As far as the first part, everything went pretty much just as we had trained. The rendezvous was just beautiful. The deploy went exactly as we had hoped it would go. The only little glitch we had was when we tried to berth it. Mark and I both practiced long hours to get the berthing completed within a certain period of time, and we basically do it 2 ways. We use visual cues with our cameras, and then we also use instrument cues by looking at numerical values of the arm position inside the orbiter. And when we got there, we had a perfect arm position and we had perfect visual cues, but we still didn't have indications that we were ready to latch the Spartan down in its berthing mechanism. And so we spent just a little bit extra time tweaking the arm so we could get those ready to latch indications that we were hoping for, and that took, I guess about an extra 15 or 20 minutes or so.
This is Bill Harwood with CBS News. A question for Mark Lee, please. It really seemed like you got spun up pretty good there your first time, which I found intriguing anyway. I was wondering what your first reaction to that was, and if you had any jokes with Carl after the spacewalk was over.
Well, just a little bit. You know, we're shooting for 30 degrees a second, and until you do the first one, you don't know. So Carl had the toughest one because, you know, you don't know until you do that. And I was pegged out at 30 degrees. I would guess I was maybe 40 or 45 degrees. And up here, that's the only difference between like 4 pounds and 5 pounds of force. So, you know, it's a very, very, you know, minor difference. But once I fired the attitude hold to see if that works, the jets just really started firing, and I was concerned then if we kept doing high rate maneuvers, we wouldn't have enough fuel to finish out the maneuvers. And I ended up right at our bingo, which was 25%, and a little bit later on, Carl was a little bit higher than that. So I think the first maneuver took a little bit more gas, but other than that, it worked out great.
I'm Elaine Hines, WESH-TV for Commander Dick Richards. The shuttle runway will have a new surface when you come back in for a landing here at KSC. Since you've never practiced a landing on this new surface, does that cause you any concern?
Not really. I've tried to review the messages that came up. In fact, they came up with a drawing of the new surface about 5 minutes before this press conference, and the objective was to try to read that in anticipation of a question about this, but I was unable to do that. As I understand it, a significant portion of the runway has been now smoothed, which, at least in my mind, is certainly in the direction of goodness. And the brief glance I got of it indicated that the runway's markings are such that there's going to be no problems with respect to discriminating where the runway center line is in the event of sun glare or a little bit less optimum visibility than what we normally have. So I'm not concerned with it, and in fact, it ought to enhance our landing performance just largely from the fact that it increases the margin on our tires. So just having glanced at it briefly, it looks like we're going in the right direction, and certainly positive for tomorrow as far as I'm concerned.
This is Marcia Dunn with the Associated Press. For anyone on the crew, with landing just a day away, I'm wondering if you're ready to come home, or do you wish you could spend more time up there and maybe even take Safer out again if you could?
Well, Marcia, that's a kind of a mixed question here because we're real proud of the work we've done, and we've done all our tasks and objectives. So, from that aspect, I'm sure we're happy with what's happening and ready to come home. And it's pretty fatiguing up here. I think a lot of us are looking forward to getting home, getting a good shower, and some good old earthbound things we enjoy. However, of course, I think given another day or so, to be up here, if we had the chance, we'd all jump at it just because it's an opportunity so rare. And once you're here and adjusted to it, it's a fantastic environment to work in.
This is Beth Dickey with Reuters. I'm going to make this a toss-up and let you elect which one of your group is maybe the most eloquent. If you had to choose the single most important expected outcome of this mission, what would it be?
Well, that's not really a fair question. I think the single most important outcome that we can come up with at this moment is that our mission has continued to prove that there's a lot of different things we can do in the space program, and we can use the shuttle efficiently and effectively to accomplish a whole host of objectives. We've been doing Earth ops, we've been doing contacts with ham radio operators on the ground, talking to them about spaceflight in general, getting them motivated. We've also, of course, had the very well-publicized LiDAR in space experiment. We've got the SPIFEX, which measured the plume impingements of the shuttle's own control jets, and that's extremely important experiment for moving on to our next stage in spaceflight, which is docking missions with Mir and our own space station. In addition to that, we also had the Spartan, which was an astronomical experiment studying the sun and its effect with solar winds on our own Earth's atmosphere. So when you line up all the things we've done on this flight, it's not really fair to try to pick out one that's most important. I think the most important thing that we've done with our flight is emphasize that the shuttle's there for a number of people and a number of reasons, and we can pretty much do it all.
This is Todd Halverson of Florida Today for Susan Helms, I guess. Can you give me an idea? You've been up there for 9 days. What's the first thing you're going to want to do when you get back?
Well, let's see. I think the first thing I'm going to do is wash my hair. I can't help but think that a hot shower and getting my hair clean is going to be a neat thing to do when I get back.
This is Phil Chen. Keep the mic, Susan. Before the mission, we had talked about what the Earth looked like, especially at night. So I'll follow up my question to Jerry. What does it look like at night? Anything particular you've seen, especially the superstorm Melissa?
At night, as I say, really a lot of city lights, and it seemed like most of our passes that I looked out was over Europe, and you could pretty much spot the coastlines because of the concentration of population along the coastlines, and of course also the major inland cities. Storm at night, I think Susan had a look at that, and she was up on the flight deck, and I don't know how she sleeps through day-night cycles up there, but I was sound asleep during some of that, so I'll pass it to Susan to follow up on the storm.
Okay, on Rev 84 to 85, I did happen to be awake. It was about an hour after the start of sleep time, and I was not expecting this. I did not see this on my last flight, but I looked out the window and saw coming toward the orbiter, right over the nadir of the orbiter, this humongous eye of Super Typhoon Melissa. And my major regret was that it was sleep time and everybody was asleep, and I couldn't run around the orbiter yelling at people to come take a look. We went right over the eye. I think the light folks actually got an excellent data take on it, and I looked down the center of the eye as we went over and saw close to just clear blue water with just a scattered to broken layer way down at the bottom of the eye, and it was awe-inspiring. I just can't describe the feeling I felt of the power of that storm. It was just beautiful and tremendous to think that that kind of stuff exists on Earth.
Bill Hartwood with the final question from KSC, and again, it's to Mark Lee, and it's the same question I asked him before. I appreciated the engineering answer, but I was really curious as to a more human gut level reaction and what that felt like, and if you and Carl joked about that a little bit after the EVA.
Well, from the rotation standpoint, I wasn't worried because I knew the safer unit could do the job. In training, we spun it up to much faster than that, and it came out of it. But it did surprise me, the number of jets, and I was just, sitting there for a little while, I go, I hope I stopped, That was the only time at all that I was, concerned at all during flying, and that was only, a little bit that, and the jets did their job. But you always have those little, when you're doing something for the first time, you always have those questions, is the software going to work right, or is the flight control system going to work right? And so I sat there for a little while wondering whether or not the system was going to function as planned, but it did. So we were very happy. I was particularly happy.
Houston, this is KSCPAO, and that concludes the event.